All right, so for those of you that are still trying to figure out maybe when you might want to use elimination or how to use elimination, I'm really going to try to show you a couple different examples here and also, when I might choose to use it. I am not always going to use elimination. I'm not always going to use substitution, and I'm not always going to use graphing. It really depends on the situation. So when you look, I have three problems here. I've got, actually four problems, sorry, 11, 14, 17, and 7. So we're going to look at all of those different problems. When I look, for me, when I'm thinking about situations in which it's pretty clear cut that I would choose to use elimination personally, the one that comes up most frequently for me is something like 14. And the reason is elimination is exactly what the name says. It's solving a system by eliminating one of the variables, because the problem in a system is that we have two variables, and I can't solve two things at once. I can only do one thing at a time, especially me. I'm not a multitasker. So for me, like, I want to get rid of one of these variables. I wish there was only a single variable, and that's what elimination does. We eliminate a variable. So in order to do this, the reason this one screams elimination to me is because of the organization of it. You see how I have like all the x's and they're kind of nicely lined up, and I've got all my y's nicely lined up, and I've got all my numbers nicely lined up. And the reason that's so nice is because what elimination does is basically we're just combining two equations. And it's easiest to combine two equations, and by combining I mean add or subtract. It's easiest to combine two equations if everything's lined up, and the equal signs have to be lined up, because we're going to combine the left-hand side of the equations. We're going to combine the right-hand sides of the equations. We're combining the two equations exactly as they're written. And so if everything's not nicely lined up, I can just combine them the way they are. So for instance, if I chose to add this, that would be 3x. 3y minus 4y is subtract y. And then that would be equal to 31. Now, why in the world would you do that, you say? Well, there's no good reason to do what I just did, at least that I can think of offhand, because I wasn't able to eliminate a variable. You see, I still have x's and I still have y's, and that's a problem. I don't want two variables, I want a single one. So let's go back, and if I choose to do something different, so I can't eliminate them yet. If you look at the reason why, well, x plus x is, or x plus 2x is 3x. They don't get rid of each other. The only way that I could get them to get rid of each other is if I had the same number of x's in this equation as I do in this equation. So how could you do that? Well, I think about equations as like orders at a concession stand. I can always go up to a concession stand and place an order, and then I can choose to double that order or triple that order. I can do whatever I want. Of course, they're going to double or triple the total, the cost, but I can double my order and they'll double the cost. So I can do those kind of things to equations. So here, I notice that the x's, there's no way I can't add or subtract them to get rid of them, nor can I with the y's. So I've got to change an equation. So for instance, I could take that order, that equation, and I could double it. And in so doing, I would get 2x plus 6y equals 14. And now when you look, this would allow me to take this equation, and I can combine them nicely to eliminate some things. So let's go ahead and do that. I'm going to go ahead, and if I'm going to get something to eliminate, well, how is 2x going to eliminate 2x? I'd have to be subtracting them. So really what that means is I want to subtract both equations. So 2x minus 2x is nothing. I don't have to write it down. Negative 4y subtract 6y, because I'm subtracting the equations, right? I'm subtracting right there. So negative 4 minus 6 is negative 10y It's going to equal, because everything's nicely lined up, 24 subtract 14 is 10. And that's why elimination is so nice. I eliminated a variable. And from here, it's just simple algebra. I can solve, get y equals -1. And then, I can use this, my result that I got right there, and I can go back and plug it into either equation to find my x value. Now keep in mind when I do that, so like x plus 3 multiplied by -1 equals 7. Okay, so x plus -3 equals 7. So x equals 10. Or if we come down and do the other one, which I'll do that one in orange right here. So we could do, 2x minus 4 times -1 equals 24. And that -4 times -1 is +4, so our 2x plus 4 equals 24. And then 2x equals 20, because I'm subtracting 4 from both sides, right? And then that's going to lead again to x equals 10. And so we can see it worked out. So again, just to recap quickly, elimination is a way to eliminate variables. And the way that we do that is by adding or subtracting two equations. And sometimes, like we did right here, we need to multiply an equation in order to get another equation that we could use to eliminate a variable. So, let's look at the other ones. That's not the only time I'm going to use elimination. I mean, I can get flexible and use it just about whatever I want, honestly. It really is just a matter of how we use it. And by the way, I didn't have to eliminate the x's. I could have eliminated my y's right there in that blue one. But I would have either had to multiply one of them by a fraction, or I would have had to change both equations. And I could do that. Matter of fact, maybe that's important. So let's show that. So I could do this, and then I have 2x minus 4y equals 24. And so right now I can see that 3y and -4 are not going to cancel. I could make 3 into 4 if I multiply by 4/3. That's going to be kind of sloppy. Maybe I don't want to do that. So I could make a 3, what could I make 3 and 4 both into? 12. So I could multiply this one by 4 and get 4x plus 12y equals 28. And then what could I do to this one? Well, I need to make that 12, so I'm going to multiply it by 3. I get 6x minus 12y equals, let's see, 60 plus 12, 72. And now if I look at those two equations, I can see I have 12y in both of them. One's positive, one's negative. So how would the y's cancel out? Well, they would cancel out if I added them, yielding 10x. Nothing for the y's because they cancel each other out, equals 100. And so dividing by 10, we get x equals 10, the answer we got before. And then again, we could find the y. So we can use elimination very creatively to reduce the variables from 2 to 1 or from 3 to 2. And we do that by combining multiple equations. All right. So let's look at something that, so like right here, for most students, that one screams like, hey, use substitution. You know, I can set this equal to this because they're both equal to y. And that's so true, and there's nothing wrong with that. But I just want you to see that we can be creative. I could use elimination right now. Look at it. What variable is it set up nicely to eliminate? The y's. Also, look at the structure. You see how the y's are lined up and the x's are lined up and the 7 and the numbers are lined up? That just spells easy to combine those equations. And so what I'm going to do is that I could get the y's to eliminate if I take the two equations and I subtract them. And so y minus y is 0 equals, because that's my left side, now I'm working on my right side, x subtract negative 2x, that's 3x. Negative 2 minus 7 is negative 9. And if you look, I've eliminated, I now only have one variable. I could add 9 to both sides, get 9 equals 3x, and I could get x equals 3. If I needed to do that algebra. We probably already knew what the answer was, but whatever, you get it. So even in a system that looks like it's set up perfectly for substitution, and it is, I still can use elimination quite effectively. All right, so not bad. All right, take a look at number 17. Right now, the way that problem's set up, you see how my stuff's not really lined up? Like my y's would have to combine, and then my equal signs are all weird. And this one doesn't scream elimination to me. Now, don't get me wrong, I could still do it. I could actually do it pretty easily. It's just the structure doesn't make me think of it. So here I probably would use substitution. I would put that in for y because it's really equal to y. See right there? So substitution would probably be my choice here. But since this is the elimination talk, we might as well look at it. I'm going to stretch these equations out. So y equals 2x minus 1. And then we have 3x. Oh, I'm going to rearrange that one. Negative y, this is the second one, plus 3x, because that's a positive 3x, equals negative 1. Now, when you look at this, what I did is I just rearranged the equation. And the reason I stretched out this top one is because I wanted my equal signs to match up, because my left side is going to be combined with my left side on the equation, and my right side on my right side. And then I rearranged the bottom one because I wanted the y's to kind of line up. So when you look at this, again, I can use elimination. What variable seems to be able to go bye-bye? The y's. So positive y, negative y, I could add here, get 3x equals, well, there's nothing combined with the 2x on the right side, so it's 2x. And then negative 1 and negative 1 makes negative 2. And here, again, I've eliminated a variable. I can just keep solving now that I have a single variable. It's not so bad, and then I can plug this in and find one of my y values into either equation. Okay, so I'm not finishing the problem off. I want you to understand that. I'm just showing you, hey, we can do this. Elimination is a pretty nice method. Here I didn't even need to multiply. Sometimes it just works great. So anyway, I hope this helps. I hope you see when we can use elimination. If substitution's your problem, well then make sure you talk with me. But elimination is a strategy that can be very, very nice and make it so we don't have to deal with too many multiplications and additions and parentheses and distributions. So anyway, hope this helps. Have a great weekend.